Alright, this is lesson 6.1, area between curves. What you see here is a graph of two functions on the xy plane. And the first function is y equals 5x minus x squared. The second function is y equals x. Now, with the intersection, they form a region between them. And this region has a certain area which you want to solve for. So I'm shading the area right now. This is what we want to calculate using integration. What we actually end up doing is taking the area of the larger curve, and so that would be this bell shape here, and from it we subtract the area underneath this other function, y equals x. So it's this whole section minus this triangle section, and what you end up is the shaded area. Now, algebraically, what this comes out to is now this region goes from x equals 0 on the y-axis to x equals 4 because these graphs intersect at 0.44. So the integral we want to take is the integral from 0 to 4 of this first function, y equals 5x minus x squared, minus the lower function, y equals x. And you get this integral. So when you solve out with algebra, you get, well, let me see if I remember integration. You get 5 over 2 x squared minus x cubed over 3 minus x squared over 2 evaluated from 0 to 4. And when you plug that in and get numbers, it comes out to, let's see, 16 times 5 over 2, because you plug in 4 for x squared and e squared, you see, minus 64 over 3 minus 16 over 2, which comes out to be some fraction that I don't feel like calculating.
40 minus 21.3333 minus 8.
Okay, yeah, Kevin likes math. So you get 40 minus, what is this?
21.3 repeating.
0.3. Oops. That goes in the, does it go on the top or the bottom?
Top.
Top, that's right. Okay. Minus 8. Which
so you get
equals
32 minus 21.33.
Yeah, which is 11 point,
which is
10.667.
We did math.
Okay, and that is the area between these two curves, as you can see, and that is lesson 6.1. Okay, time to erase.
Okay, this is a problem where the equations are in respect to x, so you can't solve this from top to bottom. You're going to have to use the integral from right to left. So we're going to do right minus left, and we're going to find the area, this area between these two curves. And the two curves are 2y minus y squared, and we're going to subtract y squared minus 4y from that equation. So the integral is going to look like this. And the point of intersection is from -3 to 3. So the integral is going to be from 0 to 3, the y coordinate, of 2y minus y squared minus this equation right here, y squared minus 4y. And if we're to solve that algebraically, we get 2/3 y, we get y squared minus y cubed over 3 minus y cubed over 3, so those can cancel, no, they add together, minus 4y squared over 2, which just simplifies out to 2y squared. So we get y squared minus y cubed over 3 minus y cubed over 3 minus 2y squared. So you can cancel that. So we have negative y squared. So we have negative 2y cubed over 3 minus y squared from evaluated from 0 to 3. So if we're to solve that, we get negative 2 times 3 cubed over 3 minus 9 minus
oh my gosh, I'm
0.
so sorry.
So we get 27, negative 54 over 3 minus 9. Let's just do that. Negative 54 over 3. So we get negative 27 is our final answer. Because when you plug in 0, these all just turn into 0. So negative 27 is the answer, and that's the area between these two curves.
This is section 8.1, which is arc length. So we want to find the length of the curve from here to here, and the formula for arc length is the integral from a to b of the square root of 1 plus f prime of x squared. Yes. So for this one, it's from 1 to 3, so a and b are 1 and 3 respectively. And then we have to take the derivative of y, which we can do over here. So y equals 2/3 x squared minus 1 to the 3 halves. So you differentiate with the chain rule, and you get y prime equals x squared minus 1 to the 1/2 times 2x. And now all you have to do is plug it into the formula. So that'll give you 1 plus x squared minus 1 to the 1/2 times 2x squared dx. And this is kind of complicated to solve by hand, but it ends up giving you 15.333 or 46 over 3.
Man, we're good.
Good job.
Brilliant.
You just like cut left.